for low-code data mining, and the first tutorial that we are going to go over is the multi-class classification. And here are the import statements and the installation process. So where you just install Pycaret, and then we quickly set up the data where for this one we are using the hard data set of Pycaret, and the setup involves importing the classification file of the Pycaret library, and then we set it up, and then we target the death column of the data set. Death column is this one. And what we do further is we import the classification experiment as well. So Pycaret has two sets of APIs that you can work with: function and then object-oriented API. So I think this is part of the object-oriented API where we import the classification experiment. So we set it up as well, and then target column is death again, and then we compare the models. So we compare the models and then get the best model. So best model here is CatBoost, as its accuracy is very high, and then we compare the models using OOP. So the experiment classification experiment stuff we had involves comparing using OOP, and again the CatBoost is the best model we have. So we analyze the model and then plot the confusion matrix. So it looks like this, and then we do the awk plot as well, where you show the ROC curves, and then feature importance plot is drawn, and we further create help so that we get help of the plot model to just see what plots are available. These are all the list of plots that are available, and then we go on to evaluate the model, and then we these are all the plots that are available, and we can go on to everyone, but I don't think some of these will work because okay, they will work if the runtime is connected. So this is how it works, and you can switch back to the previous one as well. And the previous one that was already on the screen was a pipeline one. And now what we can do is we can create a prediction on the test set and then show the top half of the data or the head of the data from the predictions. And then what we can do is we can create a data copy and then drop the death column just to predict the model on new data. So here's what we are doing. We want to predict death column, and this is based on the new data that drops a death column, right? And then further we save the pipeline, and and then load it. So here's how the pipeline looks. Numerical imputer has a symbol imputer inside, and then it goes into categorical imputer, and then it finally goes to catboost classifier. So this is how it is, and then for the purpose of this classification, we aren't gonna go over the whole detailed function by function overview, but I can show you the create app which uses Gradio, and as we need to run a demo on it, here's how the create Gradio app works. What we can do is we can go onto this link, and it's gonna open the Gradio app for us. And what we usually do is we're gonna put all the values on here, and then we're gonna click submit, and it's gonna predict the death column for us. So here's how it that works, and I can probably use a data set. It doesn't have a very good accuracy, I think, but we can still try as we are using the heart data set here. It is. What I can do is I can choose the first column and then try to predict the data. Try to predict the death column. 42, 110, 65. 110, 65. Right, and then it's going to be 64, 147, 291, 2. 47, 291, 2. And then we have 8, 4, 120, 78. 8, 4, 120, 78. Right, and then we have 271, 146, 2. 271, 146, 2. 271, 146, 2. Okay, so I feel like we're missing a column here, and let's just check over it. 42, 1, 110. I think we missed the second column. So I'm just gonna switch all the values on here. It's gonna be 146. This is gonna be 271. This is gonna be 78. This is gonna be 120. This is gonna be 4. That's gonna be 8. That's gonna be 2. That's gonna be 291. That's gonna be 147, 64, 65, 110, and it is 42, 1. And that's all we need, and then we'll submit and see what it outputs. So the prediction score for 1 is 0.7558, so there's going to be a death for this one, and it predicts it correctly. So that's our Gradio demo for the first one, and we'll move on to the next model. So we have the regression model, and then we go into the data set where it starts. So in the regression, again we import the stuff and then install it. So I already installed it, so it's not showing for some reason, but I already installed it on here, and it's going to use the insurance data set, and then the target column would be charges. So that's the setup we are having. And we are also going to use the object-oriented API. So we are using the regression experiment for this one. Then we are setting it again, and the column is again charges, and then we are comparing the models. So these are the three models that we get that are the best for this use case. And we are going to avoid errors. What we did was we used cat boost model and created it. Further, we created residual plots for the cat boost regressor model, and we also created the error plot, prediction error plot, and then we also created a feature importance plot, and then we evaluate the model. And so once you evaluate, what happens is it's going to show you all the plots that it can create as categories. It's not showing here for some reason, but what you can do is you can switch to each plot and see what it creates. And it also creates a default pipeline on here, and it shows that here we are going to predict on test set, and this shows the top half or the head of the data, and then we're going to drop one column for regression as well. So we're dropping charges to create a prediction model, and then we are predicting model on new data that doesn't have charges. And then further we are saving the pipeline and saving the model, and then we are loading this pipeline. This is how the pipeline looks. So another thing I can do is I can show you the, as we are supposed to show two Gradio apps. Here's the other one that we have for regression, and it has four values. Again, you would do the same thing for this data set as well. What you would do is you would put on the values and then predict the last column, which is going to be what? The charges column that we dropped. So that's going to output that, and I can go on and describe the next one because this one's done. So let's look at the cluster. So let's look at clustering, and we install Pycaret and then import it. And here we are using the hard data set, and it's going to predict depth as what we did for multi-class classification. And then we set up the functional API right here. For clustering, we import all the clustering files on here, all the clustering models, and then for the API, object-oriented API, we are using clustering experiment and then setting it up again. So this one doesn't require a target data set, as we are making clustering and not really a prediction model. So we're creating a k-means model right here, and then we can see what models are available to use. So these are all the models, and we are using k-means. And also we are creating another model using mean shift, and we are creating a k-means cluster and assigning the model, which is what it's going to do is going to assign cluster labels to the training data. And then further we analyze the model using a cluster plot. So this is how it looks, and then we also create the elbow plot, and then we also create the silhouette plot, and then we evaluate the model. So it's going to show us all these things. As the runtime is not connected, I wouldn't be able to show all the other plots, but this is the pipeline plot as default. And we are making a prediction on k-means, and this is how it looks. Now we save the model, and we also sorry to misinform at the start, but this is also predicting, and it just doesn't have a target row. So we are saving this pipeline and then displaying the pipeline right here, and we can go on to the next one. And what it's gonna do is gonna do anomaly detection. So this basically looks over the outliers and anomalies in the data set and predicts what could go wrong and what is wrong. So we are using the juice dataset for this. We are setting it up right here. This is for the functional API. And then we're setting it again for the anomaly experiment, which is going to be the object-oriented API. We're setting up the data and then creating a model, iForest model. And then we're checking these are all the models we can use. And we are using iForest first. And then we're assigning labels, anomaly labels to the training data right here. Then we are gonna make a TSNE plot to analyze the model for outliers. So this plot is specifically for outliers, and this is how it shows. Then we evaluate the model, so it's going to show us all the different plots types we can use. And this is a pipeline plot. The TSNE is the other one, the previous one. And now we are going to predict the model. So this is we are going to input the data, and then we are going to further save the model as a iForest pipeline, and we are going to load the pipeline. So here's the loaded pipeline, and we can go on to the next